In this video here, we're going to take a look at solving geometrical problems. Now we can use the fact that the vector product A cross with B is perpendicular to both A and B to solve problems involving planes and lines in 3 dimensions. Now before we look at some practice questions here for solving geometrical problems, we can also note that the shortest distance between two skew lines with these given equations here, where lambda and mu are simply scalars, is given by the following formula. So as you can see then, we have the following result here. So we take the modulus then of the full expression. So we have A minus C. We then dot that with this vector product here, so B cross with D. And that's all over the magnitude or the modulus here of B cross with D. So please do make a note of this result here, right? This formula, this result is not given in the formula book. Okay. So there we have it in terms of an introduction here to solving geometrical problems. It is a very quick introduction, but we don't need too much more than that. So what we're going to do now is work through a couple of practice questions for solving geometrical problems. So let's get started then with question 1. So for question 1 here, it asks us to find the equation of the line of intersection of the two planes pi1 and pi2, where pi1 has this equation here and pi2 has this equation here. Now, hopefully you notice straight away then that this vector here is the normal vector to pi1, and this vector here is a normal vector to pi2. So what that means then is that the line of intersection of the two planes pi1 and pi2 must be perpendicular to both normal vectors. And what that means then is we can simply use the vector product to find the direction vector. Okay, so let's just make a note here then. So for the direction vector, here, all we're going to do then is use the vector product. Okay, so we obtain our 3x3 determinant. Along the top row, we have the unit vectors I, j, and k. Along the middle row, we have 2, -1, and 1. And then finally, along the bottom row here, we have 1, -2, and -3. Like so. Okay. So let's just expand along the top row here then. So what do we get? So I get I times by, across this row, this column, I get -1, 1, -2, and -3. So -1, 1, -2, and -3 here. Let's keep going then. So we now get -j times by the remaining 2x2 determinants. So across this row, this column, I get 2, 1, 1, -3. So 2, 1, 1, and -3 there. And then finally we have plus k times by the remaining 2x2 determinants. So across this row, this column, I get 2, -1, 1, and -2. So 2, -1, 1, -2 there. Okay. So let's just evaluate then each 2x2 determinant here. So I get -1 times -3, which is 3, minus -2 there. But altogether we get 5i there. So we get 5i to begin with. Let's keep going then. I've now got 2 times -3, so that's -6. -1 times 1, so -6 minus 1 is -7. Times that by -j, we get plus 7j. Okay. And then finally here we have 2 times -2, so that's -4. Minus -1. So I've got -4 plus 1 there. So that gives me -3. So I get -3k there. Okay. So this here then is the direction vector. Okay. Now for the next step then, what I'm going to do here is write the planes in Cartesian form. Okay. So let's write the planes then in Cartesian form. So for pi1 then, what we get here, this would be 2x minus y plus z is equal to 4. Okay, so for pi1 then, as we've just mentioned, we get 2x minus y plus z is equal to 4. Okay, and then for pi2 here, what do we get then? Well, I get x minus 2y minus 3z is equal to 3. So x minus 2y minus 3z is equal to 3. Okay. And what I'm going to do now is set z equal to 0 and solve simultaneously. It doesn't have to be z equals 0. You could also do this with x equals 0 and y equals 0. I've just chosen z equals 0 here arbitrarily. Okay, so set z equal to 0. We'll set z equal to 0 and solve simultaneously. If we do that then, I get 2x minus y is equal to 4. So 2x minus y is equal to 4. And what do I get here? So I get x minus 2y is equal to 3. So x minus 2y is equal to 3. Okay. And all we need to do now is solve these simultaneous equations here. You could also just use your calculator to solve these simultaneous equations. That's fine. But what you should get here then, so for x then, we get 5 over 3. So x is equal to 5 over 3. And for y, we obtain minus 2 over 3. Okay. So what this gives me here then is a point on the line. Okay. So therefore, I've got 5 over 3 minus 2 over 3 and 0 lies on the line. So let's just make a note of that here then. So 5 over 3 minus 2 over 3 and 0 lies on the line. Okay, it lies on the line here. That lies on the line. But at this point here, then, we now have everything that we need then for the equation of the line here. Okay, so to finish with here then, the equation for the line, or the equation of the line of intersection, here is given as, we have the vector r here is equal to, so we have our position vector here, so that's 5 over 3 minus 2 over 3 and 0, like so, plus lambda times by our direction vector here. Okay, so our direction vector here then is 5, 7, and minus 3. So 5, 7, and minus 3 there. Okay, and there we have it. So this here then is the equation of the line of intersection of the two planes pi 1 and pi 2, and that gives us the solution to question 1. So to finish with here then, let's have a go now at the very last question. So we have question 2 here, which asks us to find the shortest distance between the two skew lines L1 and L2 with these given equations here where lambda and mu are scalars. So for further pure 1 here, given that we've now introduced the vector product, we now have a new way to find the shortest distance between two skew lines. And the way that we do that then is by using the following result here. So we have the vector A minus the vector C. We dot this with the cross product then of the vector B and the vector D, like so. This is all over the magnitude, or the modulus, whichever you prefer to describe it as, of the vector B cross with the vector D. Okay, and we take the modulus then of this full expression. Okay, and this result here then will give us the shortest distance between two skew lines. So let's just label this vector here then as A, this vector here as B, this one as C, and then finally this one here as D. Okay. So to begin with here then, let's just find separately the vector A minus the vector C and the vector B crossed with the vector D, because once we've evaluated both of those separately, we can then easily evaluate the shortest distance between the two skew lines L1 and L2. Okay. So starting off then, the vector A minus the vector C, nice and straightforward here, right? So for the vector A, that's 0, 1, 1. So 0, 1, 1. Minus the vector C, so C is 5 minus 2 and 2, like so. If we evaluate this difference here, then nice and straightforward, right? 0 minus 5 is minus 5. 1 minus minus 2 gives us 1 plus 2, which is 3. And then finally 1 minus 2 gives us minus 1 there. Okay, so this here then is the vector A minus the vector C. We also need to evaluate the vector B crossed with the vector D. So the vector B crossed with the vector D. So for the vector b crossed with the vector d here, all we need to do is evaluate a 3x3 determinant. So we have our 3x3 determinant here. Along the top row, we have I, j, and k, our unit vectors here, like so. Along the middle row, we have the vector b, so that is -1, 1, and -1. And then finally, along the bottom row here, we have the vector d, so that's 4, -2, and 3. Like so. Okay. So to evaluate this 3x3 determinant here then, let's just expand along the top row. So if we do that then, what do we get here? So I get I times by the remaining 2x2 determinant here. So across this row, this column, we get 1, -1, -2, and 3. So 1, -1, -2, and 3 there, like so. You then get -j. Oops, don't forget to put the line underneath here, just to indicate that this is our unit vectors. We then have -j, and we times this by the remaining 2x2 determinant across this row and this column. So I get -1, -1, 4, and 3. Like so. And then finally here we have plus k, and we times this by the remaining 2x2 determinants across this row, this column, and we get left with -1, 1, 4, and -2 there. 4 and -2. Okay. So what we need to do now then is evaluate each of these 2x2 determinants as we go. We have 1 times by 3, so that's 3, minus them. So I've got minus here, -2 times -1, so that's going to be 2. So 3 minus 2 just gives us 1, right? So we just get I there, like so. I've got -j times by this 2x2 determinant here. So -1 times 3 is -3. -1 times 4 here gives me -4. So I've got -3 minus -4. So that's just the same as -3 plus 4 there. That would give me 1. We have -j times by 1. I just get -j there, like so. And then finally here, we have -1 times -2, so that's 2. -4 gives us -2, so we get -2k there. Okay, like so. So now we have everything that we need then to find the shortest distance here. So let's just make a note of them. So a note here for the shortest distance between the two skew lines, L1 and L2. So shortest distance. So shortest distance between L1 and L2. So what we're going to do here then is use this result. So the vector A minus the vector C, we've already evaluated that, right? That's -5, 3, and -1. So I'll put the modulus bars in a little bit later on. But what we're going to get here is -5i. So -5i plus 3j plus 3j minus k here. So this vector here then is just the vector A minus the vector C, right? -5, 3, -1. We dot that with B cross with D, so that's this result here. This is B cross with D, like so. So we dot that with this vector here. So I minus J and -2k there. And this is all over then the magnitude. It's all over the magnitude of this vector here. Okay, so it's all over the square root then of the following. I'm going to get 1 squared plus -1 squared plus -2 squared. We get 1 squared plus -1 squared plus -2 squared. Okay, like so there. And don't forget then we take the modulus of this full expression. Okay, let's just simplify this here then. So -5 times 1 is -5. We've got the modulus here of -5. 3 times -1 is -3. And then finally -1 times -2 gives us +2 there. So this is all over then the magnitude of this vector here, which is the square root of 1 squared plus -1 squared plus -2 squared. which is nice and straightforward, right? That's just 1 plus 1 plus 4. We get the square root of 6 here, like so. So we simplify this here, then what do we get? So I get minus 8 plus 2, so that's minus 6 here within the numerator. If we take the modulus of this result here, or this function here, what we get left with then is 6 over root 6, okay? Now it doesn't ask for the answer here in a specific form, so you could just leave the answer like this, and that would be absolutely fine. But a nicer way to present the solution here is to rationalize the denominator, okay? If we do that here then, times top and bottom by root 6, we get 6 root 6 over 6. Clearly the 6's will just cancel, and we get left with root 6 there, okay? And there we have it. So this root 6 here is the shortest distance between the two skew lines L1 and L2 with these given equations here, okay? So there we have it. That gives us the solution to the very last question, question 2. And that brings the end then of this video here on solving geometrical problems.